Welcome to another video. I'm going to go through some homework solutions from Homework 3. So let's take a look at number 1. Refer to the elements to complete the following table. So the information on the left is what you will need for each of them. So you're going to look at number 5b, 53i, 47ag, etc. to figure out that information. So let's take a look at the periodic table. So if we look at each of the elements in turn, we have first is boron. Boron is number 5, and of course we know that they go in sequential order, so here's boron. Number 5, we have iodine, which is right above my video window here, number 53. Next is 47 silver, Ag, there it is, in the transition elements. Number 20 is calcium, on the left in group 2, and finally is plutonium, which is not on this periodic table, but we're just going to do boron together. So boron is number 5, and it is 10.81 is what its atomic mass says, or atomic weight. So that is 10.811 as it says right here. So this is boron. Its atomic number is the one found in the top left, number 5. The atomic number also tells us the number of protons in the nucleus and the number of electrons. So 5 and 5. So all three of these numbers, atomic number, protons, and electrons, will be the same. The atomic weight is this, and this is its atomic number. The only thing you'll have to refer to the periodic table is for the name. So if we take a look at number 2, atoms that have an outer electron shell that is not completely filled can form ions by losing or gaining up to 3 electrons. With what you know about the periodic table, predict the charge of the ions that will be formed by the following elements. So let's take a look at, let's do 3 of them. Let's do lithium, we'll do nitrogen, and we'll do carbon, one more then, magnesium. Let's find them on the periodic table. Lithium is on the far left, and magnesium, which I have already done if you have watched the atoms and bonds video. We have nitrogen and carbon. Nitrogen is up here on the right, and carbon is right next to it. So let's figure out the trend, which we have gone over already, but let's do it again. So over here in group 1, all of these have 1 electron in their outer shell. The next group 2 has 2. And then of course we skip the transitions, so we're not concerned with those. Boron, the column starting with boron has 3, carbon has 4, nitrogen 5, oxygen 6, fluorine 7, and over here we have a full outer shell. So it's important to think about what is the most favorable thing to happen in this case. So we know that the elements in group 1 are the most reactive, that 1 electron makes them extremely, extremely reactive, and they will catch fire and explode, do all kinds of things. So that's why lithium and sodium and hydrogen are so dangerous, because they desperately want to get rid of that 1 electron. And as we move to the right, we get more and more electrons in that outermost shell. But let's think about it from right to left. So if we think about it from starting where it's full, we're taking away 1, we're taking away 2 electrons, we're taking away 3 electrons in that outer shell, so it's becoming less and less full as we move to the left. 4 electrons, taking away 5, 6, and 7 taken away. Of course, if we add these up, then we get 8. So if we look at lithium, we know that lithium has a single electron in its outermost shell. So this is just the outermost shell. It's got 7 empty spaces. Lithium is going to get rid of that. We know that that's going to happen because it's easier to get rid of 1 than to get 8. That's just not going to happen. It's not favorable. It takes too much work, too much energy. Nature is lazy. It just is. It's going to take the easiest path. So it's going to get rid of that 1 electron. Same with magnesium, except it's going to instead get rid of 2 electrons. Because magnesium, if we change lithium here to magnesium, it's going to have 2 electrons in its outer shell. It's so much easier to get rid of 2 electrons than to get 6. That's just not going to happen. So these 2 are going to leave. And I think I said get rid of to gain 8 electrons. I meant 7 for lithium, but I think you get the idea. So we're going to get rid of these 2. And if we move the other way, let's take a look at carbon. Carbon, if I draw a picture of carbon, I'm not going to draw its inner shell, just the outermost one. It has 1, 2, 3, 4 electrons and 4 empty spaces. Now, here's a hint. This is a slightly trick question on this. In this paper here is that carbon is not going to either get or give away electrons. It would rather share. So carbon does not ionize. Not like this anyway. We might be able to force it through certain chemical reactions, but not in nature. It would rather share those electrons because it has the same number of electrons missing as present in that outer shell. And this is what makes it so wonderful for life, is because it's such an incredibly flexible and versatile atom. But over here, if we take a look at nitrogen, nitrogen is very similar to carbon, except it has 1 more electron. There's 1, 2, 3, 4, and 5 in its outer shell. So if nitrogen is going to turn into a nitride ion, that's what we call it, it's not going to lose 5, it's going to gain 3 because that's more energetically favorable. It's easier to get 3 than to give away 5. So let's figure out what those charges are in the next slide. So we decided we're going to do everything except we're not going to do chlorine or any of these. You can do those on your own, but we'll do these 4. So lithium we know is going to get rid of 1, right? Because if we draw this is not what I'm looking for. But if we have lithium, it's going to get rid of that 1 electron. It doesn't want to keep that. So this correct answer is Li with just a plus sign, or +1. Either one's okay. Because if lithium started with 3 protons and 3 electrons, and it got rid of 1, and it has 2 electrons, that means we have 3 plus charges and 2 minus charges. So if you do the math, 3 minus 2 is +1. So this is the correct answer for this question. For magnesium, we decided that magnesium is going to get rid of 2 because magnesium in its outer shell, not any of the others, it has 2 electrons and 7 empty spaces. So it's going to get rid of these 2 and it started with 12 protons and 12 electrons. And if it got rid of 2 electrons, that means it has 10 electrons. So 12 minus 10, so 12 plus minus 10 charge is going to give us a +2 charge, or 2 plus, I'm not picky, because we lost 2 electrons. So our charge goes up as we lose electrons. Now carbon, we said, does not ionize. I wish it wouldn't connect my eyes like that sometimes. It gets a little confused with the dots. And nitrogen is very similar. I'm going to draw it over to the left, except it has its atomic number 7. So it has 5 electrons in its outermost shell, and it's going to gain 3 electrons from some source or multiple sources. It's a little light. Gain 3 electrons. So as it gains them, its charge is going to go down. Remember that electrons are negative. So it started with 7 protons, and 7 electrons, but if we get 2, we're going to add 3 to that, and now we have a 10 negative charge and a 7 positive charge. So the charge for nitrogen is going to be -3, or 3 minus, I'm not picky, but there you go. So this is the kind of format I'm looking for, like this K+ here. The last question I'm going to go through for the homework, because the rest is about that graph, is the difference between ionic and covalent bonds. Now, they are very distinct types of bonds, and they do different things. The most important difference is how the electrons move. In ionic bonds, we see what we call a transfer of electrons. Where electrons actually jump from one atom to another and change their charges. And so an ionic bond is an attraction between a negative ion and a positive ion. So if we do HF as an example, this is the simplest one I can think of. H has 1 proton and 1 electron, and F has 9 protons and 9 electrons. So if we draw our H, we have 1 electron in its outer shell with 1 empty space, because it only has 1, it's in that lowest shell, and fluorine has 2 in its lowest shell closest to the nucleus, and 1, 2, 3, 4, 5, 6, 7 in its empty shell and in its outer shell and 1 empty space. So this electron is going to be lost from the hydrogen and will join fluorine instead. And so when these two are bound together, hydrogen will simply be a positively charged proton, and fluorine will be negatively charged because now it has an extra electron from hydrogen. I'm running out of space. There we go. Here is hydrogen's electron that it donated, right there. And this is an ionic bond. It's an association between positive and negative atoms or groups of atoms. In a covalent bond, it's a sharing of electrons. They're going to share instead of transferring because that's what's more favorable for them. So there is no change of charges. And this is just redistributing the electrons to be around more than one atom. And our simplest example is of, say, H2. We know that hydrogen has one proton and one electron. So if we have a hydrogen, I've already done this already in homework and in class, but I'll do it again. Doesn't matter where you put the electrons, I'm just doing this for simplicity's sake. So these electrons are going to come together. Each electron is 1/2 of a covalent bond, because one covalent bond is 2 electrons, and they will form a bond together. And I like how your book represents it like this, where it shows them overlapping, to where if we were to cover up, if I just delete this hydrogen here, if we just have this hydrogen on the right, those electrons count towards both. And if we just have the hydrogen on the left, those electrons count for that as well. All right, well, I hope this helped you a lot. Have a great day.